Hi, I'm Sam Kenkel, the DevOps lead for Meshify. I focus on highly performant, reliable distributed systems. I've been doing this in a couple different industries over the years, starting with video. These days, I work primarily within IoT, keeping our platform performant and stable, and that includes our databases such as Scylla. I'm Sam. I'm the DevOps lead for Meshify. Wall of text there, I'm not going to read any of it. DevOps in our context means that I worry about reliability, scalability, and performance of Meshify's product/platform. So who is Meshify? We were founded in 2010. We were purchased by the insurance company Hartford Steam Boiler in 2016. Hartford Steam Boiler is himself owned by Munich Reinsurance. We provide the platform for HSB, our parent company, and its parent company, Munich Re, to develop IoT products for insurance. So let's talk about what that would look like. So as an example use case, let's say you have a water puck that looks like this that goes in a floor somewhere and does a pretty good job of telling you if it detects water. And let's say that you have a temperature probe right here that you attach this metal point to a pipe. If you're talking about actual preventable flooding, most of that is caused by a pipe freezing then bursting. So if you have a temperature probe attached to a pipe and the temperature in that pipe is dropping at the same rate as the temperature in your zip code, and the temperature in your zip code is predicted to drop below freezing, that's a really good sign that you should probably send someone to your facility and do something about that. Let's say you don't, and you ignore the first strongly worded text message. Well, when the pipe actually hits freezing, you can send a much more strongly worded text message saying your pipe's already is gone, but you can still cut off the water and prevent some of the damage. If that doesn't go so well for you either, then a thing on the floor like this will tell you there's water on your floor, which at that point, every minute that water leaks, there is more and more damage, which you and your insurance company have to deal with. So what do we do with Scylla? So as I talked about, we ingest data from sensors. This data is processed, augmented, and stored by some Golang microservices. We compare that data to user-defined alarms. In our case, the users would be our parent or our grandparent company. We send alerts, SMS, email, and webhook, and we allow for API calls to access this time series data. We also have a front end that allows for visualization of some historical data. So all of our time series data is in Scylla, which is the values of every sensor forever. Every time a sensor enters or exits an alarm state. So what I mean by that is you have this temperature probe. Well, you can put this to a pipe to detect if that pipe is going to freeze, or you can put this in an industrial refrigerator to detect if that refrigerator has failed and all your food's about to spoil. In that case, the alarm state would be in one case going too high, in another case going too low. We also keep as the time series data of every time our platform sends notification. So this is a database conference, not a DevOps conference. Let's talk a little bit about what it takes to have a reliable, performant platform that has to be up all the time so that you can know when things go wrong all the time. So microservices 101, intro to DevOps. So most of our platform is stateless. A bunch of containers, they spin up, they do something, they die. This is great because containers die. This is great because hosts die. This is great because networks die. As a TLDR in computers, all of them die all the time. This also means that we can scale the parts of our platform, microservices, separately. So if one microservice is taking more resources, we have to scale up that rather than all of it. There's this idea, key to DevOps, which is pets versus cattle. The analogy is when your pet gets sick, you take it to the vet. When your cattle gets sick, you cull it from the herd and replace it. So let's talk about state. A little harder to do that. So inside containers, you can have your state be attached on launch, an EBS, some type of persistent disk. The container can preserve state in that way, but this means that the application has to handle all of the failure tolerance of a failure that's mid-operation. The other way to do this is have everything containers, everything stateless, and have all your state in a managed database. This is popular. Sometimes this is like serverless or no ops, which is let's pay AWS, GCP, or Azure and let them deal with all this. Okay, great. We don't do that. Our nodes are neither managed nor containerized, and let's talk about why. So it's important to us that we have some vendor neutrality. We only use cloud services that have drop-in replacements of some type, either open source or from other cloud vendors. In the case of MySQL or Postgres, you can go back from the cloud to on-prem. You can go to another vendor's option. If you're using DynamoDB, Amazon has a tool that lets you migrate to DynamoDB, but getting away is a much bigger deal at that point. It's important to remember that there is no cloud. There's only someone else's server, which is useful sometimes. So the other things that happen is you have issues of locality and performance. So what we do is we use AMIs and EC2 instances, which means I can answer with confidence what region is my data in, which, because of GDPR, matters a lot. It also means that I can answer with confidence how has the performance tuning been set. Managed services are making trade-offs, even if the trade-off is as simple as how much you're paying Jeff Bezos for how much performance, or more complex. To summarize a bunch of other talks going on here, Scylla's performance isn't free. Scylla's performance versus Cassandra comes from more direct access to the hardware and the fact that it's more aware of the underlying hardware. So what do? So I have this term, Petshop Seamonster, entitled the talk, which is, for those of you not from San Francisco, a pet shop is a place where you can go and buy an animal that's identical to other animals. They're kind of banned here. That's what I think of our Scylla nodes. We use the Scylla AWS AMI. These are pre-tuned, and what actually happens is if you deploy the AWS AMI on the correct size of i3 instance, the node detects what it is and drops in the correct performance tuning settings. This means I can deploy a new node in about 5 minutes. This means there's not variance from misconfiguration. This means that I have the consistency of containers and I have the performance benefits of kind of a well-tuned instance. If you don't think that this matters as an experiment, go ahead and build yourself a Scylla node and then freeze it and change the underlying hardware, either RAM or CPU or IOPS, and don't rerun the benchmark tools, and watch what happens. It's not going to go well for you. So in practice, a node fails. So a node dies, an alarm goes off. We use Datadog, or you can use their monitoring solution, the Grafana stack. It goes to our pager thing, which wakes someone up at night. We launch a new node using an AMI. It takes about 5 minutes for us to launch a new node once we're into the AWS console. It takes about 5 minutes to add this node to the cluster and to start streaming data to this node. Right now, this is manual, so we can investigate why we lost a node, but nothing I've described could not be an AWS Lambda that's triggered by our pager system. Talk about scale out, scale in. I want more or less performance for more or less money. So we add a larger or smaller node of the kind of pre-tuned sizes. In our database right now, we can migrate node to that data in about 2 hours, and then we remove the old node. You do want, when you're doing this, to end up with every node to be on the same size of instance, and the fine folks at Scylla can explain why that is. But the short version is that if you have a heterogeneous cluster, then your performance is defined by the worst node in your cluster. But heterogeneous clusters are fine if you are, round robin scaling up or scaling down. We prefer running exactly 3 nodes, and when we want more, we scale all 3 of those nodes up. And if we want less, which hasn't happened yet, we would scale all 3 of those nodes down. We keep this manual because we want to be in the loop when we send AWS more money every month. But again, if I wanted to, I could automate this with some lambdas. Let's talk about disaster recovery. I'm paranoid, but disaster recovery is great. So worst case scenario, I lose all my nodes. I lose the AWS region. It has happened in the past. So we launched 3 new nodes using the AMI. It takes about 5 minutes for the nodes to spin up, and then we just restore our schema. And as part of how our platform is designed, once the schema is restored, we can send those core alerts out again, even though we can't give people access to their previous time series data. So as the SSS table loader is moving, then the system is still functional, and you do that. Then we batch all the old data in. I can do this in under 15 minutes. I'm not sure anyone else in my company could do it that fast, but I practiced this a little bit because I'm paranoid about disaster recovery. So that's kind of what we're using with Scylla and how we are kind of trying to have the benefits of the modern microservices, containerized stuff of I don't really heal nodes. I don't really like in the previous talk. They talk about what happens if one node goes 1% slower than its peers. My answer is what happens when I discover that one node is 1% slower than my peers is I kill it and replace it. And that is, in short, kind of how we keep our system both stable and performant. And all the work here is based on the fact that the AWS AMIs are pre-tuned to those specific cluster sizes, the EC2 sizes. And that's kind of where most of our, and because of that, we get all these cool benefits.